Welcome back to another lesson on trigonometry. You can see here that I've summarized some results from the previous few lessons. Notice also how I've left a blank space in 4 places. That is what we're going to pursue today. You'll remember how we obtained these values from the square, the equilateral triangle, and the pentagon. Now we are going to employ some of our trig identities to obtain the missing pieces to this puzzle. Notice, sine is in ascending order, 0, 15, 18, 30, up to 90, whereas cosine is in descending order, 90, 75, 72, etc., such that the angles 15 plus 75 is 90, 18 plus 72 is 90, 30 plus 60 is 90. Okay? You'll remember that pattern also from a few lessons ago. So we're going to exploit it for our purposes here. Let's begin with sine of 15 degrees. For this, I'm going to use the angle difference formula. So sine of 15 degrees is equal to sine of 45 degrees minus 30 degrees. And you'll remember from the angle difference, that is equal to sine 45 cosine of 30 minus cosine 45 sine 30. Of course, there's more than one way to skin a cat. We could also use the half angle identity, starting with sine 30 to get the answer. If you feel so inclined, I encourage you to do so in your own time and check that it matches the result we obtain here. Now, it's a matter of plugging in the values. So sine of 45, that is root 2 over 2. Cosine of 30, well, that is root 3 over 2. Minus cosine of 45, root 2 over 2. And sine 30 is 1/2. All right, a little simplifying. 2 times 3 is 6, so root 2 times root 3 is root 6. 2 times 2 is 4. Root 2 times 1 is root 2. 2 times 2 is 4. We have a common denominator, so I can simplify root 6 minus root 2 divided by 4. That is sine of 15 degrees. It's also cosine of 75 degrees. So I'm just going to fill this in. Root 6 minus root 2 divided by 4. Okay, now let's jump ahead to sine of 75 degrees. For this, I can use the angle sum. Changing the negative to a positive, sine of 75 is 45 plus 30. So this changes to a positive, positive. Boom. That was fairly straightforward. Root 6 plus root 2 divided by 4. Wonderful. Now, what do we have left? This guy and this guy. Again, there's multiple ways we could do this. We could use the double angle identity with sine 18, but what's the problem? We would need to know cosine 18, which we don't yet know. So, what if I use the half angle identity instead? Sine of 36 degrees is equal to the square root of 1 minus cosine of 72. It's the square root of the entire quantity. Okay, so now it's a matter of plugging in. 1 minus, okay, cosine of 72 degrees is right up here, negative 1 plus root 5 over 4. And all this is divided by 2. Okay, 1 can be rewritten as 4 over 4 because anything divided by itself is equal to 1. So now we have a common denominator 4 minus a negative 1 is a positive 5. A negative root 5 pops out here. And 4 is in our denominator. Well, 4 times 2 is 8. And it's the square root of all that. Well, what if I multiply both the top and the bottom by a 2? Now 2 times 8 is equal to 16. Well, the square root of 16 is 4, so I can factor out a 1/4, and that is 5 minus root 5. Okay, so that is sine of 36 degrees. 1/4 times the square root of 2 times 5 minus root 5. Okay, great. So now we have one remaining quantity to find. Again, there's multiple ways I could do this. Now I know sine of 36. I could use the double angle identity to find this. Or I could go back to the Pythagorean identity. So what is that? Sine of 72 degrees is equal to square root of 1 minus cosine squared of 72 degrees. So what is cosine of 72? That's this guy again. So I'm going to have 1 minus negative 1 plus root 5 over 4 squared. Square root of all that. All right. How do you think we're going to find this? If you said FOIL, you are correct. I'm going to FOIL that out. Negative 1 plus root 5 over 4 times negative 1 plus root 5 over 4. Well, negative times a negative is a positive 1. Negative root 5 and another negative 1 times root 5. And root 5 times root 5 is 5. 4 times 4 is 16 in the denominator. Up top I can clean up a bit. 1 plus 5 is 6. Negative root 5 minus another root 5 is going to be minus 2 root 5. And that's all over 16. All right, so to bring it back up here, well, 1, let's get a common denominator. 16 over 16 minus this guy. 6 minus 2 root 5 over 16. All right. 16 minus 6 is a 10. And negative times negative gives me a positive 2 root 5 over 16. I can factor out a 2. 2 times 5 plus root 5. I can take the square root of that. Square root of 16 is 4. So I'm left with a very similar looking answer. The only difference is a positive versus a negative sign. Isn't that interesting? So let's write it down here. 1 over 4 times the square root of 2 times 5 plus square root 5. Now you've seen the exact values for some specific angles of sine and cosine. It is possible to continue this pattern using the identities to split up angles, add them together, and so forth, until we reach a limit of 3 degrees. You can of course keep chopping that up, but it's no longer going to be a whole number of degrees. Also, the expressions here get quite a bit more unwieldy, so I'll leave it there for now. I wanted to demonstrate the point of how we can obtain these exact values using trig identities.